One is a graduated cylinder contains 5 liquids, each with a different color. The color and density are as follows. Gold is 4 grams per centimeters cubed, red is 2.5 grams per milliliters, black is 4.55 grams per milliliters, white is 1 gram per milliliter. How much you guys want to bet that white's going to be on top of it all? And purple is 3.5 grams per centimeters cubed. List the order in which these liquids will appear in the graduated cylinder, I'm assuming. Okay, so not too hard. So first things first, I just want to cover one thing before we do get into that. This is not hard at all. It's just conceptual, but really quick. Let's do pink. Cool. So density is either, the answers for density will always be in grams over milliliters, or it would be in grams over centimeters cubed. Centimeters cubed is the same thing as milliliters. So if you ever have 3 milliliters, it's the same thing as saying 3 centimeters cubed, okay? I just want to cover that. And this is relevant to what I'm getting to. Volume is usually expressed as milliliters or centimeters cubed, as we just stated up there. So if something's 105 milliliters converted to centimeters cubed, it's still 105 centimeters cubed. They're the same thing. Not a big deal. Mass is usually given in grams. Sometimes if they want it in kilograms, go for it, but grams is usually what it is, the way we do it. To solve for density, when you need to find density, you need to do the mass over volume. When you need to find volume, like volume is what you need to solve for, it's mass over density. And if you ever need to find the mass, the easiest one, density times volume. You don't have to memorize this. I've been deriving it the whole way through, but I'm just telling you guys, I actually just remember it. I just remember it because I just derive it primarily in my head. But just remember this, okay? The answers, that's how they're usually given. So look at this, grams over centimeters cubed, okay? Not bad. Grams over milliliters, not bad. So grams over milliliters, white is grams over milliliters, and last but not least, purple is grams over centimeters cubed. So this is kind of why I'm telling you, because some of you guys will be like, oh my god, we have to convert this all. I mean, right off the bat, I'll tell you this one, convert it all if we want to keep it consecutive, like I don't know, kilograms over meters cubed. It's irrelevant, basically, is my point, what I'm trying to get to. All these mean the same thing, right? Because grams over milliliters or grams over centimeters cubed. See, grams over milliliters, grams over milliliters, grams over milliliters cubed, grams over centimeters cubed. Okay, so don't get tripped up on that. I just wanted to cover this to explain that very quickly. So now let's put these in order. So the first one is, I don't want to use that color anymore. It's getting old. It's giving me diarrhea. Gold. Gold. We're just gonna put a 4. We're gonna ignore this part. Ignore those parts on all of them. Okay, just for right now. Gold is 4. Next is red is 2.5. Black is 4.55. Whoops, no, 455. White is just 1. And purple is just 3.5. And I'm just going to go over it. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Wonderful. So now I'm going to draw my graduated cylinder. Okay. In chemistry, I hated it. We used to almost drop these all the time. So which one here has the biggest density or the biggest number? We'll go to the bottom. So number 1 obviously would be black. Go to the bottom. Who's the next one? Looks like gold. Gold would be number 2. Next biggest one, we got purple. Next biggest one would be red at 2.5. And then white. Wow, freaking races. Oops, white. Yeah, white would be on top, and wow, and black is on the bottom. Dang, even science is racist. So let me explain that really quick. When we have, let's say, a cup, you threw oil on the ground and then you filled it up with water. So this part is H2O and this part is oil. Oil goes to the top. simply because water has a higher density. It's like thicker in nature. And you'd be like, well, oil's slimy, but it has nothing to do with its molecular structure. And by the way, fun fact, H2O, the way to say it is dihydrogen monoxide. Let's go to ice. You ever wonder why ice floats? Probably don't because you're a normal person, but let's just learn that right now. Why is it that ice goes to the top but water stays in the bottom? They're both H2O, right? Except one is frozen, one is not. Well, have you ever seen movies in Hollywood where people shoot at like someone jumps into the water and then these bad guys come and shoot the water and the bullets stop? Kind of like they can't keep traveling because it has no resistance. Well, there's other variables, but outside of resistance and stuff like that, it's denser. It's harder to pass through it. Ice, it breaks. It's not that strong. So water has a higher density than ice cubes. So the bigger the number, the bigger the density, the number associated with this densities, the more I guess to the ground it would go, right? So if you had something that was, I don't know, 75 grams over centimeters cubed, and something with 100 grams over milliliters, this one go to the bottom, this one go to the top. Okay, so I hope that helped you guys.